Let's look at the sign of the parabola. They're asking to find the interval where the sign is positive, where f of x is greater than or equal to 0. This is opening up. It's always going to be greater than 0 because the vertex is at 10, 1, and it's opening up. Let's get some values on here. You don't have to pick the actual values. I could just go 2 that way and then 2 this way and say, okay, the parabola's going to look something like this. But I'm going to find the exact values. The x equal to 10 equals 2 times open bracket that x value minus 10, 0 squared is 0, plus 1 gives us 1, 10, 1. Let's see what it is when we were at 8. The x is at 8, we get 9. It's going to look something like this. We want to know the interval when f of x, when the y values are positive. Well, the y values are always positive when x is a member of the reals. And then we press answer to see if we're right. This one's opening down, and we want to know when it is positive. The vertex is above the x-axis. It's at 3, 7, and it's opening down. It's going to look something like this. We want to know when it's positive. Okay, let's get some real points. Negative 6 times minus x value minus 3 squared plus 7. When it's 10, we're at negative 287, so that's not very useful to us. Let's see when it's 1. What do we get? Negative 17. Okay, good. So this b value is at 1, we're at negative 17. Negative 17. That is 2 away from the vertex. So if I go 2 away on the other side, we should also be at negative 17. When x is equal to 5, we get negative 17. When x is equal to 4, we get 1. 4, 1. When x is equal to 2, we should also get 1. 2. We get 1. The parabola looks like this. They want to know when is it greater than 0? When x, from this point to this point, we have to find the zeros, solving for x when y is equal to 0. Here we have f of x is equal to negative 6 times x minus 3 squared plus 7. But we need to know the zeros in order to figure out when the function is positive. We get the zeros. I'm going to set the y to be 0. So 0 is equal to negative 6 times x minus 3 squared plus 7. I want to get rid of that 7, so I'm going to subtract 7 from both sides. We have negative 7 is equal to negative 6 times x minus 3 all squared. Divide both sides by negative 6 to get rid of this negative 6 that's multiplying the bracket. A negative divided by negative is positive. We get 7/6 is equal to x minus 3 all squared. Now to get rid of this squared, I'm going to take the square root of both sides, but when you do, you have to put a plus minus. Okay, so we have plus minus the square root of 7/6 is equal to x minus 3. We're going to get rid of the negative 3 by adding 3 to both sides. We end up with 3 plus or minus the square root of 7/6 is equal to x. 3 minus the square root of 7/6. That should be our x1. I need to have an equals in front of this for it to work. And our x, does that make sense? 1.91, almost 2. Yeah, that makes sense. And our x2, so I'm just going to fill this down because all we have to do is just change this minus to a positive, a plus. We end up getting 4.08, which does make sense here. These are our two values. X is positive between these two values. When x is a member of the first value, so I'm going to put a excepto bracket, this first value, 1.91987, comma 4.08012. I put in 5 decimal places in each case, then put the excepto bracket like that. It's positive, the y values are positive between this x and this x. And we press answer to see if we're right. Let's do another one where this is opening up because the a is positive, and the vertex, the h is 0 because we don't have brackets. The k is negative 3. It's opening up. So it looks something like this. Let's find exactly what it looks like. You don't have to do this. This is probably enough. X is equal to 0, and the y is equal to 6 times this x value squared. Take away 3. Calculate. Negative 3, which is 0, negative 3. Let's see what it is when x is equal to 1. Well, we have positive 3. 1 and positive 3, like that. This would be negative 1, positive 3 as well. Let's put in negative 2. Let's see what that is. 21, so it's way up there. It's opening like that. And they want to know, well, when is it negative? When is it less than 0? So between this 0 and that 0, we need to find the zeros. To find the zeros, I'm going to set the y equal to 0, like that, and then solve for x. I'm going to add 3 to both sides, and that gives us 3 is equal to 6x squared. The 6 is multiplying the x squared. I'm going to do the opposite. I'm going to divide both sides by 6. That gives us 1/2 is equal to x squared. To get the x alone, I'm going to take the square root of both sides. And that gives me plus or minus the square root of 1/2 is equal to x. We're going to start off with negative the square root of 1/2 and then positive the square root of 1/2 equal to negative the square root of 1/2. That gives us negative 0.7, so a little bit more than 0.5. That makes sense. Then this is going to be positive that. Let's fill this down, double click, and put a plus in front of the square root, or just remove the minus. It is negative, all right, so f of x is less than 0, but the function is below the x-axis when x is between negative 0.707106781, positive 0.707106781, when x is a member of, excepto bracket, negative 0.7071066, 6 decimal places, 0.7071066, the excepto bracket. That is our solution. Then we press answer to see if we're right. Here we want to know when it's positive, this is opening up, and we are below. This one's going to be fun. I want to find the vertex, which is positive 5, negative 5. X is 5. The y value is equal to 9 times, open bracket, the x value minus 5, close the bracket, squared, minus 5, which gives us minus 5. 5 and negative 5 like that. It is opening up. Let's find some other point. When x is equal to 4, 4 is right here. When x is 6, we're probably going to get 4 as well. When x is 7, what do we get? 31. Well, that's way up there. When x is 6, we get 4. We want to know when is it positive. And that's going to keep opening up. It's positive from negative infinity up until the 0. Now we have to find the 0. We're going to set our function equal to 0 to find those zeros. Now I want to get rid of this negative 5. I'm going to add 5 to both sides. And that gives us 5 is equal to 9 times x minus 5 all squared. I want to get rid of the 9 that's multiplying the bracket. So I'm going to divide this side by 9, and I also have to divide that side by 9. The 9's cancel. I get 5 over 9 on that side. So 5 over 9 is equal to, open bracket, x minus 5, close bracket, all squared. I want to get rid of the squares, so I'm going to take the square root of both sides. That gives us plus or minus the square root of 5 over 9 is equal to x minus 5. Now to get rid of minus 5, I'm going to add 5 to both sides. That gives me 5 plus or minus the square root of 5/9 is our x values when the y is 0. These are my zeros. I'm going to start off doing 5 minus the square root of 5 over 9 is equal to 5 minus the square root of 5 over 9. And that gives us 4.25. Does that make sense? Yeah, it does. It's going to copy this down and change the minus square root to plus square root. That gives us 5.745. Yeah, real close to 5.75. This is positive. When is f of x greater than or equal to 0? It's positive when x is a member of negative infinity, because this is going to keep on opening up and up and up. So from x is negative infinity until this first 0. X is a member of, rejecto bracket, negative infinity until the first 0, which is 4.254644. Union, because we're putting it together with this region when x is a member of, open bracket, 5.745355 to infinity, rejecto bracket on infinity. This is the answer.